Okay, so what we're going to do today is reporting category 3. So what is reporting category 3? It's going to be our quadrilaterals, which is our four-sided polygons. Polygons in general, we have to know what the sum of the interior exterior are and how to find each one of interior exterior and how many sides things have. Circles, measures of angles formed, lengths of segments, arc, area, and equations of circles. The SOL puts equations of circles as its own thing, so it's a pretty big topic for us to go over. That's why I separated it. Surface area and volume and similarity of 2D and 3D shapes, in case you forgot, that's the ED area and volume chart. So the first thing I'm going to look at is polygons. As soon as you get your scrap paper and your formula sheet and all that on the SOL, I would write this down. Some of this is common sense. In a triangle, it has 3 sides. How many degrees is it? 180 degrees. In a 4-sided shape, how many degrees is that? 360. In case you did not know where to find that, I can look up at a rectangle. I can look at my computer screen. I can look at a square. You guys know that it's 90, 90, 90, 90. Put that in your calculator, you get 360. How do I get from 180 to 360? What do I add? 180 degrees. Every subsequent, all the rest of the shapes, when I add one side, guess what I'm going to add? So this becomes 540. If I have 6 sides, I add 180 again, and it becomes 720. 7 sides, I get 900. I can keep going forever. If the SOL asks you how many degrees is inside of a 42-sided shape, you guys have unlimited time. You can literally sit there and add all the way up until you get to 42 sides. Now, that's how much the inside adds up to. How much does the exterior angles add up to? All the angles on the outside always add up to the same thing. No matter what. So no matter how many sides I have, it's always 360. If I'm dealing with something on the outside of the shape. These 3 angles that I'm putting dots on are going to be my inside. My outside generally means I'm going to have to extend a side, and that's one exterior. And they add up with an interior to be 180. Now, if I want to know what each interior angle is, or each exterior, I'm going to separate these by the number of sides I have going on here. Each interior, I'm going to take my sum, which is 180, and I'm going to divide by the number of sides. And I get 60. Over here it's going to be 360 divided by 4, or 90. 540 divided by 5, or 108. 720 divided by 6, or 120. And finally, 900 divided by 7 is going to give me some kind of freaky decimal. It's one of the only ones that gives me a decimal. And it is 128.6. Now, what I know about my interior and my exterior angles, if I'm going to do every exterior angle, this is my favorite thing to do, it never changes. This number is always 360. Because my exterior is always going to be the same, and I'm going to divide by the number of sides. Now, without using a calculator, pretty quickly I can come up with all of these. This one's a little bit trickier. And I get 51 points. And guess how I came up with those so quickly? These two add up to 180. These two, these two, these two, these two. They add up to 180. So even if I don't know the number of sides, I can come up with the number of sides because 360 divided by the exterior will always give it to me. And if I'm given an interior, I can find my exterior. I always work towards my exterior because it's always 360. And I can't mess that up. So let's go on to the next one. Quadrilaterals. You guys know these things, and I can just prove it to you. I just said how many degrees is in a square or a rectangle. What shape is this? A rectangle. And ever since you were a little kid, you've learned a couple things about rectangles. You know that those are 90. You also know that your opposite sides are congruent, because that's how we define it. Now, the newest property we have deals with my diagonals. In a rectangle, my diagonals are congruent. So that's the only new property I have, but I can get through that. The other shapes that I know is I have a square. My 90-degree marks are not looking really good. I also know what a trapezoid looks like. You guys have seen trapezoidal tables. I know that those are parallel. Sometimes those are equal. That would make it an isosceles trapezoid. The coolest thing about these, a kite, is one of my favorite. You guys have been drawing and making kites ever since you were little. You put two sticks together in the middle. That would be 90. Cut some paper out. You knew that those two are equal, and those two are equal. You have to be able to, the whole purpose of geometry, if you haven't learned it yet, is to take a picture or some kind of property that you know, pull out the algebra, and solve. That's what you need to do. So let's keep going. My formula sheet. What I need to know about my formula sheet is up here. These are all my two-dimensional figures, and these are all my three-dimensional figures. I can't find volume of a two-dimensional figure. It has to be 3D. Generally, when I have this big V here, this shape, and this shape, my prism and my pyramid are the ones that I don't have a set base for. Over here, my base is a circle. My base is what I have two of or one of in a pyramid or cone. I have two circles, that's my base. How far apart I pull them, that's my height. So up here, even in this, I have one. How far apart I pull my string to make that point is my height. So you have to know that. You have to know the difference between height up here and slant height down here. Because it's just a formula. You cannot miss these questions on the SOL. Generally, they're going to give you everything you need on this formula sheet, and you're going to have to figure out where to put them. Anything else special about the formula sheet? Just know how to use it. That's my biggest piece of advice. If you don't practice, they might have you going from one shape to the other. If you know the volume of a sphere, you might be looking for the lateral area of a cone. So if we go through rather quickly, because I did mention it, we have volume, surface area, and lateral area. Surface area is kind of like if I wrap a present. Volume is if I fill that present. It's what's going to go on the inside. And then lateral area, which is kind of a little bit different, is like a soup can label. But it starts with LA. So when I think of a label of a soup can. So those are the three things I need to know. So if it's asking me for something, I know what to look for. So I kind of go through those things. length, and area of sectors. That's still formula sheet stuff. When I think of it, I think of a piece of pizza. When I eat pizza, I hate eating the crust. I just don't like the crust. The crust is kind of like my arc length. It goes just along the outside of that piece of pizza. Now, if you ate the whole slice of pizza, that would be considered sector area. So I either have arc length or sector area. Now, this all deals with circumference and area. Sector area has the word area in it. My formula sheet told me area equals pi r squared. Arc length is going to deal with my circumference, which could equal pi times the diameter, or 2 pi times the radius, depending on what they give me. So I need to know how much, and generally they're going to give me an angle. No matter what, how many degrees is in a circle? 360. Whatever angle they give me goes there. And then I multiply. I have to pick C or A. I have to pick my circumference or area. So normal pizzas are probably, let's just say it's a 14-inch diameter. Okay? They normally cut a pizza into an equal number of slices. They normally cut it in about 8 slices. So if I ate one slice of pizza, 360 divided by 8 gives me 45. So each slice is 45 degrees. If I want to know how much pizza I ate, I want the sector area. So I'm going to say 45 out of 360, and I'm going to multiply by the area. If 17 is my diameter, 7 inches is my radius, and I'm just going to put that in my calculator and get a number. Everyone know how to put fractions in the calculator. If you don't, you are going to hit alpha, it's a green button, and y equals, and then just hit enter. And a fraction bar looks kind of like this. Will pop up, and you just put in your fraction. It reduces my fractions for me. It does a lot. So that's why I use that. Let's keep going. So, comparing things. Whenever they give me two shapes, one could be a big one could be a little one. If I'm comparing shapes, I always throw out my EE, area, and volume chart. What does EE stand for? It stands for everything else. What do you think the A stands for? Area. What about the V? So if I asked you for the perimeters, you would go to EE. If I asked you for the scale factor, you would go to EE. If I asked you for the area, you go here, under area. Surface area, still here. Lateral area, still here. If I ask you for volume, you go there. The most important part of this chart is going to be my EE. I have to make it back to my EE. If they give me area, I cannot go from area to volume. The little exponent, you guys see how this is a 2 and a 3? This one is a 1. That means that's where I always have to go back to be able to get to the other one. For example, if this is 4/9, in order to undo something that's squared, I have to take the square root. So in my calculator, I would put the square root in. I would do my alpha y equals, I'm going to get this lovely thing here, and I'm just going to type in 4/9. When I hit enter, I get 2/3. Now, I just go ahead and raise this to the 3rd power. Where do I find that 3rd? When in doubt, I hit math. If I'm in Desmos, it's not as bad. I could actually make a fraction in Desmos pretty easily and just cube it. It ends up giving me 8/27. So my chart's filled in. Well, what's the purpose of this chart? What if I don't have pictures and I have to figure out how to use it? I'm going to walk you through one quick example. Maybe not so quick, hopefully quick. When I'm comparing two solids, I'm going to put solid number 1 over solid number 2. So I'm going to go to my EE chart. And I'm going to ask you, what information do I have? I have surface area for both solid 1 and solid 2. So that's the one that I want to compare. I'm going to put it here. In my calculator, I'm going to hit the square root, and I'm going to put 1296 over 1024. So square root alpha y equals 1296 over 1024, and I get 9/8. I cube it, and I get 729 over 512. I'm not done. It asked me for the volume. What volume do I have? Of 1 or 2? So is that number going to go on the top or the bottom? It's going to go on the top. I always try to work in my chart, makes it a little easier for me so I don't screw anything up. If I'm going to look at this, in trig, I asked you very specifically. I said, if x is in the top, what do we do? If x is in the bottom, what do we do? What do we have going on here? Where's the variable? So what am I going to do? I always start with the number that's over with my variable, and I say 10935, and I divide it by whatever's on the other side. In trig, that was like sine, cosine, or tangent, but now I can do it with fractions just as easily. So I say 10935 divided by what I got, and I get volume equals 7680. So I can work in my chart nice and easy. Sometimes it looks a little bit easier than it is, but I'm just going to be working with comparing two shapes. Whenever I compare, I always go to my chart. This makes it a little bit easier to organize and to get through. Now, equations of a circle. This one is a little bit different, and I want to show you test nav, because I think it's important for us to see what's going to happen and how you can study for this test. So, I can go to test nav, which I'm already in, and I can show you how to get there. If I Google test nav, I'm not even Googling test nav Virginia, by the way, just test nav. I just go there. Amazing. What state do we live in? Virginia. I can figure that much out. Do you see down here it says practice items? We actually used this when we did constructions, in case you remember, but we're going to go to mathematics 2016 because that's the closest to 2019. And I'm going to work on geometry. I could play with the audio too if I want to. I'm just going to start it up. And I have 31 questions. Now, I know a third of the test, I'm in the last third. So let me start at this and see. Oh, looks like I'm starting in the right spot. That's sector area. Oh, equation of a circle. Now, whenever I see coordinates on this test, I am going to go to Desmos. Do you see this lovely calculator up here? Looks a little bit different. I can move it around. I don't like the Desmos stuff being on the bottom, so I just scoot it on over. And I can play with it and scoot it. I want to plot this point. It told me W equals -4, 6. so I plot it. That's my W. If I want to know what it is, I can even label it. It's right there. Right there. Now, how do I come up with the equation of a circle? Well, in exhibits over here, guess what it tells me? There's my equation of a circle. I can put it right there, move my Desmos over, and I'm going to use that formula to help me out. Parentheses, x minus -4 squared plus, wrong way, plus y minus 6 squared. And guess what it equals? My radius is 10. 10 squared. So I just used my equation of a circle. Do you see how I could pull up my formula sheet? You guys are going to have a paper copy. And my Desmos at the same time. Well, this is not, it's not fitting quite right, so I'm going to make it a little smaller. Doesn't that look pretty easy so far? I want to know which one of these points is on the circle. I'm just going to go ahead and type them in. 0, 4, is that on the circle? Is this one on the circle? Right here, it's on the circle, on the red circle. This one. It doesn't look like it's on the circle. Let's try the next one. I'll label that choice A. Let's look at choice B. 2, 10. Of course I did something really weird. 2, 10. That's choice B. Is that one on the circle? It's inside the circle. I don't think it's on the circle. Let's look at choice C. 4, 0. Is that on the circle? Do you see the difference between A, B, and C? Finally, we have one more. And that's choice D. I can't even see it. Oh, it's up there. So, if you had to pick one of these, which one would you pick? C. I'm using Desmos. You guys get an unlimited amount of time on this test. Use it wisely. Just go through and see which one you want to put it on. So let's go through. I'm going to go through the next one. We answered this one. We said it was C. Next problem. Oh, if there was only some way I could actually graph a circle. Oh, that's right. They made it easy for me. I can just put it in Desmos. I'm going to graph exactly what I see right here. X squared y minus 2 squared equals 25. There's my circle. I need to come up with the center of that circle. I think from looking at my formula and looking at what I'm given that it's probably 0, 2. Does that look like it? Okay. Can I graph that here? 0, 2. Looks like it's right there. Now I need to pick another point on that circle. Well, there's one there. Oh, where is that? 0, 7. Can I graph that over here? And I'm good to go. I'm done. That's all it wanted. They wanted the center and one point on the circle. Oh, equation of a circle. Okay, I have a diameter. If I have the diameter, I need to get my center, correct? So let's go ahead and plot those 2 points again. C is at -7, -4. D is at 1, 2. I want to know, get rid of this point here, I want to know where the midpoint is. Desmos is super awesome. I'm just going to type in the word midpoint. It was no longer italicized, which means it should do it for me. Midpoint is CD. Label it. What is that point? -3, -1. Opposite. Opposite. Now, what's my radius? Well, if I label this thing M, I can go back and play with it. I'm going to say, well, what's the distance, the radius? Did I spell it wrong? Why am I not? Oh, I know why. It has to be all lowercase. Do you see the difference on how it just changed? Since it has to be all lowercase, I'm going to find the distance between D and M. How big is it from D to M? 5. Well, what goes over here? 5 squared. Desmos makes my life a lot easier. Okay, so I'm always going to try to go back to Desmos when I can. So what we're going to do now is we're going to go back through a couple of other little things. Finding arc measures and arc lengths in circles. Angles and arc measures comes first. My clue here is to look for degree marks, and I have 4 different pictures I'm going to go through. On the center, this is my central angle. This reminds me of the pizza. I have a circle, it goes through the center, and there's a piece of pizza. If this is 35, probably looks a little bigger than that. This is also 35, and number 5 looks a little weird. They're the exact same. It's a 1-to-1 ratio. It goes, that vertex, that point of the angle, is on the center. Next one is going to be on the circle. I'm going to take it, and I'm going to pull that back onto the circle. There's one option. I call that a projector. Another option is when I take that point outside of the circle, I take it out. And then finally, if I leave it inside the circle somewhere, not on the center, I call it a plus sign. And here's why. I'm going to use a flashlight. If you've ever seen a flashlight shine, it kind of goes out at a certain angle and it only lights up the things that the light's pointing at. If I shine it at you and I turn around, I'm not going to be able to see anything. It's going to be dark still. So, I'm asking you where the flashlight shines. If I put my flashlight on my vertex, it's going to hit there. If I put my flashlight here, it's going to hit here and here. If I put my flashlight here, it kind of looks like one of those cool lightsabers from Star Wars that goes both directions. It can hit here and here. Now I want to show you how I work these. We know that this is a 1-to-1 ratio. A projector, I think of a movie screen. Movie screens and film has really small pictures and they make it really big. So I know that 2 times my angle equals my arc. Or I can take an angle and equals 1/2 the other. I can do either one. I like to say 2 times the angle all the time because I'm going to do that to the other 2. The next one, my take out. I go as far away as I can from my flashlight. Notice how a flashlight gets bigger the farther away you go. So I'm calling this my big arc and this my small arc. So I say big minus small equals 2 times my angle. Or I could divide by 2. Over here, I'm looking at this angle and this angle. They're vertical. They're right across from each other. I'm going to add up the 2 arcs. Arc 1 plus arc 2 equals 2 times the angle. That's all I have to memorize. 90% of the time, I'm dealing with 2 angles. 2 angles, 2 angles, 2 angles. The only time I'm not is when I'm talking about a central angle, and that's because it's a special case. How do I remember the difference between a central angle and a projector? That kind of gets me going. I kind of think of a Pokeball. I think of a Pokeball, it just took a circle and it cut it in half. How many degrees is in half that? 180 degrees. So how big is this angle right here? also 180 degrees. It's a straight line. Straight lines are always 180 degrees. Now, if I took this vertex and I pulled it back to the circle, is there any way that this angle is 180 degrees? No. It has to be related somehow. It's half. It's 90 degrees. That's the picture I remember to remember these relationships to be going. The biggest thing I can tell you is when do I need to use these? I need to look for my degree marks. If I don't have any degree marks, I'm probably not using those. Now, finally, talking about segment lengths in circles. Instead of there's no degree marks, but I have some fun pictures. One probably that looks like this. Okay, one that looks like that. And one that looks like this. So, if I'm looking at these two problems, what I'm going to do is I'm going to go ahead and highlight a few things. The first one, I call this pop, because if I have this circle and I threw it at you, it's going to pop you in the head. It's not going to hurt. It might hurt a little, but it's not going to kill you. I'm going to pop you in the head. That stands for product, which means multiply, of the pieces, or P times P. So I take one side of this, one segment there, and one segment here. And I know when I multiply them, I get an equation. So the green one, I have 3 times x, which is 3x. The purple one is 5 times 4, which is 20. I divide by 3, and x equals 20/3. I'm not going to even tell you what decimal that is. I don't care. Can I pull the math out of a picture? That's the entire purpose of geometry. Know the relationship so you get an algebraic equation and solve it. You can do that, you're golden. Here, this one, oh, if I threw that at you, I'm pretty sure you're going to be like, ow, that hurts, right? It's going to hurt. Ow. The O stands for the part outside the circle, and this one stands for the whole or entire segment. Once again, I am going to highlight these. I'm going to highlight them in different colors. There's some kind of equation I need. In the green line, what is the part outside the circle? 6. How big is the entire thing? 6 plus x. I'm going to add them together. If I forget that I'm going to add them together, I'm going to go to the purple one. Let's say I don't know what I'm doing. Let's look at the purple one. How big is the part outside the circle? How big is the entire segment? 12, because I added. Now, on the left, I'm going to use my distributive property. I'm going to get 36 plus x equals 60. 6x. My bad, I forgot to distribute. Now, I subtract 36, and 6x equals 24, and x equals 4. This is the last thing I'm going to do. I'm going to go over this one more time in Desmos. Did you guys know that you can solve equations in Desmos? Or on the graphing calculator. It's a little easier on Desmos. 6 times 6 plus x. I'm going to try to remember that. And I'm going to go back to Desmos. I'm in my test nav because I want to play with the one that I'm going to see on the calculator. The first part of that equation was y equals, it was 6 times 6 plus x. Correct? If I'm not sure, I can always go back and look. The second one was 5 5 plus 7. By the way, what number is that? 60. That tells me that A, I'm going to probably have to, ooh, I went too far. My bad, sorry. I'm going to scoot up until I get to what? 60. Where do those intersect? I know 60, but what's the answer? 4. Do you see how I went ahead and I solved that equation? So before you take the SOL, I would definitely attempt to do that. But that's it for reporting category 3.